remember? Oh, so long ago when you were in Algebra 1.
No, I was like,
You were an awkward, nerdy little 8th grader, 9th grader, 7th grader maybe. And you learned basic geometry like this, or this. They both are the same. They are still prisms, because they still stay consistent area of the base all the way throughout the levels. But the area of the base, how would you find the area of the base? Big circle, I'll call it pi, big R squared minus little circle. And then you multiply the pi by height, yay? And I suppose, given that they both have a pi, if you were so inclined, you could factor a pi out in front and an h out in back, and that would be fine. All right. Now, if you had lots of washers, the sum of many also is possible. And that's where today's lesson begins. You'll sometimes get a gap. Now, would you consider, please, this region and what happens when it is revolved around the x-axis? Now, I love drawing the three-dimensional figure. It would kind of look like a cake pan kind of deal, yeah? And it would have this kind of cone missing in the middle, yeah? But more important than that is what one washer or one slice would look like. Let me go with this big. All right, so imagine a rectangle. If I revolve that rectangle, it would have a revolution. And when I revolved it, it would have a big hole right down the middle, right? Let's draw it up. It would look like this. Okay? One slice would anyway. Now because if there's a gap between the region and the axis of revolution, the disk has a hole in it. And so it becomes a washer. All right, so we're still going to find an infinite sum of these bad boys. It's going to be the sum of infinitely many pi big R squareds minus little r squareds for the area of the base times the height, yeah? Okay, now pi, you can always put pi out front. It is a constant after all. And h is always dx or dy depending on the axis of revolution. In this case, it's dx. And the rule of when you go around the x-axis, use x, and when you go around the y-axis, use y, still applies. Not different. So at this point, then we have pi out front and big R squared minus little r squared dx is the typical starting point. You follow? And then you determine the four components. The first two components are the bounds. What are the bounds? 0 to 2 or 0 to 4? 0 to 2. Why 2? Make a case for 0 to 2. Because that's the... Okay, you don't know, you're just saying it. Why 0 to 2, not 0 to 4? Because it's dx, you should be using x values. 0 to 2 is the x value, right? Okay. All right. So 0 to 2 because we're using x as the variable of integration. Big R. Big R. Now, here's big R Big R is the distance from the axis to the outer part of the area. So, yeah, when we go from here out to here, do we go to the function, or are we every time going to that point? Here's, let me show you with a little highlighting. Here's big R. Here's big R. Here's big R. Big R is always forward. The outside is flat. And big R, the radius of the outside is always 4. Now little r, different story. Here's little r, then little r, then little r. Little r, in this case, is more like how far we go to the function, yeah? And so little r is x squared. All right. Now then, what is the antiderivative of 16?
16x.
And the antiderivative of x squared squared?
What? X to the fifth over
X to the 5th over 5. Okay. So we get 32 minus 32 over 5 minus zeros, yeah? Common denominator? 5. What is 32 times 5? Yes, 30 times 5 plus 2 times 5.
160.
160. 160 minus 32 is
128.
128 pi over 5. There's your voice. You follow? All right. I'll have you try this on your own, but first, I want to get the graph nailed down first, and then once we have the graph together, then you'll do it on your own. Okay. So give me some attributes to the graph of log base 2.
Asymptote 0.
Asymptote at
X
x equals
equals
0. Give me some points on the graph.
0, 0.
1, 0.
Oh my goodness.
What else?
2e.
2, 1. What else? 4, 2. What else? 8, 3. Okay, that should do. I'm going to go real light. I don't want to get my graph too busy here. All right, cool. What about y equals 1? Is that horizontal or vertical? Horizontal. And x equals 8 is vertical. So once I get the region enclosed, then I will solidify that. I don't want, you got too many lines going all over the place, it gets a little sloppy. All right, so it's that kind of curvy triangular region, yeah? When I go around the x-axis, or revolve that about the x-axis, this comes out of the board and back through, so it'll make a reflection over on the other side of the axis, like that, yeah?
Yeah.
And if we wanted to make a three-dimensional figure, it would look like that. More importantly, let's draw a slice or two. Here's a slice. Revolve would look like that. Here's a slice. Revolve should look like this. Now, you have two different cases now, discs and washers. Is this washer or disc?
Washer.
This is a washer because there's a gap between the axis of revolution and the region. Just so we're clear, if the region looked like this, it was right up against the axis, then when you revolve it, you get a disc. There's no gap. When there's a gap between the region, then you're going to get a washer. You're going to get a hole when you revolve it. You with me? All right. That said, find the volume. Okay. You may use a calculator this time. Unit volume is
Did you do 1 minus log?
That makes a lot of sense.
It's log minus.
Oh, it is one. Oh, it is one. Oh, that's oh, it is. That is makes sense. Oh, it is one. Sometimes you surprise yourself.
Okay, so what is big R?
Log 2x.
Yeah, each time we go from the axis up to the upper point, upper minus lower and all, in this case the upper is varied. Now we're going up to the upper curve. Log base 2 of x. Little r is here, or here, or here. That doesn't look like it's different each time. It looks like it's always the same. What is it?
Maybe 1.
Yeah, indeed. What are the bounds? 1 to 8, 0 to 8, 2 to 8? 2 to 8. When you throw that in your calculator, what do you get? 80.104. Are you with me so far? Excellent. Now let's try y. This time graph more towards the middle of your paper because you're going to revolve it around the y-axis. You're going to need reflection regions area on the side. You're going to still have this curve, this log curve, still y equal 1, still x equal 8, so it's still this region, like the one before, but this time instead of going over the x-axis, it'll go over the y-axis. Now this will be a totally different figure, so the volume will be nowhere close to the same. Down. If I go around the y-axis, I use which variable? Y and dy. If I use y, then slices go, or slices are drawn this way. That's a dy slice. It has a small vertical thickness. So when you go to draw your slices, which is the most important part, make sure you draw them correctly. Is this a disc or a washer situation? Washer. We have this big old gap between the region and the axis of revolution. And I get a hole in the middle when I do that. All right, cool. So volume is pi big R squared minus little r squared, but now the height is dy thick. All right, the bounds. What are the bounds? 1 to 3. They are y values, not x values. What is big R?
To the y. How do you get that? Just gonna put it in the y.
I disagree.
Is it 1? Is it just 8?
Big R is 8. You are going from the axis out to that point. Every one of those big R's is 8. Little r. Little r is here, then here. Ah. Little r is 2 to the y. It is to the curve, but it has to be in y terms. Yeah? All right. Say we were integrating this by hand. How would you do it?
You have to do 2 integrals.
64 minus, what's the easiest way to integrate 2y squared?
Make it 4 to the y.
4 to the y, yeah? That's the kind of gimmick or shortcut. Square first and then do the y. Then your antiderivative is minus 4 to the y over natural log of 4 from 1 to 3. We get a little gross, but it's all good. What's 64 times 3? 192 minus 4 to the third. 64 over log 4 minus, I really did a bad job of budgeting my space. 1 goes in, what do I get? 64 minus 4 over log 4, yay. So at the combining like term stage, I have 192 minus 64, which is 128. And what's negative 64 log 4 plus 4 log 4? Negative 60 over log 4. And that sounds good. All right, you with me? All right, you try. This time you may use a calculator. Focus on the concept. You still should be able to graph the region without your calculator, though. If you don't know how to graph quarterbacks, get out.
That's right.
You don't deserve to know.
That's right. Pay your dues on algebra first. A donut in math is called a torus.
What?
A torus.
Yeah, that's what it is.
Called what? Nielsen? What? I don't know what you're talking about. Leo? Is that a theorem? Not that I know of. Like Rabinovich? Oh, you don't even know Leo Rabinovich. Never mind. That's Gary. I was thinking. Never mind. 1, 2, 3, 4, 5. Oops, I have 6. We'll learn shells in 87. I like them better. Myself. That's just preference. All right.
I got 481.7. Let me see. You can't get a negative. No, you can't. Exactly. That's what I'm worried. Whoa, it's y squared squared. Y squared.
Oh, and how did you get it down?
81 minus pi over 4. I got 356.
81?
9 squared is. Why is your x equals?
Why do you have none?
Everybody's agreed. What is x equals 1 be closer to the 356?
I better go closer. So here's 1. Here's 3. Okay, so first of all, let's be clear in the region. Am I talking this region or this region? Yellow or green?
Oh, I didn't even get my region.
Yellow. Okay.
Wait, how did we get the same answer if we did different region?
It should be the yellow, not the green. I did not say anything about the y-axis. There's no reason to use the green. The only region enclosed by those 3 curves and nothing else is the yellow.
I did a completely different area.
That is really coincidental.
Wait, unless I'm wrong.
Okay, so Are you getting something like this, yay?
Yes.
All right. Pi big R squared minus little r squared. If it's around y, use y. Cool. What are the bounds?
1 to 3.
1 to 3. What is big R?
Y squared squared.
Y squared. And then big R squared is y squared squared. Little r?
1.
1. So if you did that, what do you get?
145.77.
145.77? 770?
How'd you do
Yeah.
the bounds?
So
I got the one, the one's easy.
this, so look at the lowest part of the region and the highest part of the region. The highest
Oh,
part
it's
is,
Y, okay, yeah.
yeah. Don't look left to right. Okay. All right. Let's try a little more here. Say you take the square root function and x equal 1, which is a vertical line, and x equal 3, and I think I also meant and the x-axis. So the region enclosed by those two vertical lines, the square root curve and the x-axis, is here, right? And it's revolved around the y-axis. So around the y-axis, let's see if myself not through, but it would look like this, yay? If it's around the y-axis, right away, what variable will I use? And what will the slices look like? Okay, so if I make two, would you make one between the two straight sides? 1 to 3. Then make one up here. When you make a slice up here, actually a different situation.
Oh, no.
So because of that, two totally different situations, we're going to need to do two integrals.
If we could choose, couldn't we just do the x-axis?
If you knew how to use x as the variable, it would only be one integral, but you don't. Well, that's cylindrical show.
How'd you get the 2
Two integrals because if I said this, in this case, here, what's big R and little r right here? Big R is from the axis center all the way out to the x. So big R is 3. And what's little r? From the axis center to the inner part of the region. Little r is 1. But up here, what's big R? 3. But now what's little r?
Oh,
Not 1 anymore. So that's why you need to do two integrals because it's two different situations. So it's pi big R squared is 3 squared minus little r squared. That's the lower region.
0.
And that's from 0 to 1. Correct. Because that's when the square root curve meets x equal 1. And then add to that region 2 from 1 to root 3. Because when x is 3, y is root 3. What's big R? 3 squared. And what's little?
y squared.
Y squared. And so you'd integrate those and add those, and that's we don't need. Let's go to the next one. You with me?
Yeah.
Okay. This one is a calculator active question. You need to be able to store and use your calculator well. So would you throw this in your calculator, please? Be careful how you put sine squared in. Your calculator doesn't put a. It won't take a little square like we write it. It has to be outside parentheses. So sine of x in parentheses squared. I will start over. 4 parentheses sine of x squared. I imagine no negatives, and that's correct. All right, and then x minus 1 squared, parabola right 1, boom. I'm gonna do a little zoom box action. Okay. All right. You have something like that. Are we cool? All right. Now there's only one region enclosed. So that's good. Give it a sketch on your paper. Something like the sine curve and the parabola. Something like that. Yay? We will limit our region to the intersections, the enclosure. So here is the region. The only region enclosed to revolve is that one. We? All right. So if I take some slices, if it's around x, what variable will I use? X. And if it's an x slice, do the rectangles go up and down? Now one of those slices actually does go all the way to the origin, and so there would be a single disk in here, but the rest are going to be washers, eh? Most are washers. Alrighty. So let's talk about this. Pi big R squared minus little r squared, and it's dx because we're going around x. Cool. What do I need to do to fill in the 4 places? Need some bounds. How do you find the bounds? Intersection points. Make sure you store them. You're often going to need them for multiple parts, and it's better to store them. Yeah, sometimes you will need the x and the y, but in this case, I think just the x will be sufficient. I'm getting 0.337 and 2.380. How about you? All right, so store those. When you store them, they should be bold. And we're ready to continue on. Let's fill out our bounds of our angle, 0.337 and what was it again, 2.380? Okay, cool. Big R. It's f of x. It's the sine curve. Do you agree that upper curve is the sine curve? Yeah? 4 sine squared. So you can write the function. If the functions have function names, you can definitely call them f of x and g of x. You may not call them f1 and f2 like your that is never acceptable to use calculator speak. All right, what about little r? Yeah, little r is g of x. It's the distance from the axis to the parabola. Throw that into your calculator. And let's see if we can get all the same answer without error. Make sure you type in the pi first, just as you see it on your paper. Don't forget the pi. A to B.
Oh no. Oh wait, I don't know if that's
I think yeah, you need to know which one is which.
53.
You need to have the squares right.
This isn't the science class.
You need not do sig figs. We assume there is the possibility of perfect measure. Did you get 53.998?
I sure did.
Right. All righty then. This is 53.998, and we're donners. All right, I think that is it. It's pretty straightforward. You'll be fine. And let's do some questions on the home tutor, shall we? All right, this is not number 5, actually. I think it's number 1 on the back, but you get the idea. How did this one go? All right. Let's do a little current events. What do you think, Willie? Little ethics. We're going to do, besides practice, we're going to do a little current events and a little ethics. What do you think, Willie?
Cool.
Cool, right on. All right, so, let's start here, okay? Why would it take them $100 million to develop a new drug?
The drug is money better.
It costs money, yeah, think about it. I mean, it takes a lot of scientists a lot of years, 10 to 15 years to develop a new drug. And then once you have a theory, you have to do trials for animals and then on people. And then you have to submit it to peer review, and they have to try it and make sure you're not going to kill people. And then it has to be FDA approved and all that good stuff. So it's a long, expensive process, yeah? Cool. Where do they get their $100 billion to make that pill? Investors, yeah. When you buy stock, you're loaning that company money to do their thing. So, yeah, a stock is like an investment in that company, yeah? Cool. All right, so, they're going to sell it, it cost them 40 cents to make, though, and they're going to sell it for $75. So, drug company, heartless bastards, or no, they're businessmen. Okay. So, you could go at this two different ways. You could definitely make an argument for the first, I should have said it, by the way, sorry about that. Jerks, let's say jerks instead. Make an argument for jerks. Why do you say jerks? Okay. It's okay. So yeah, I mean, kind of drug company charge basically whatever they want. I mean, if you have cancer and they have a cancer drug that'll cure it, can they basically stick it to you as much as they want?
Yeah.
You're going to pay it, right? If you can afford it, because it's your life, right? So they kind of got you over a bit. Yes? Make a argument for charging $75. They're taking, so yeah, they didn't get $100 million. They need to make their $100 million back. If they don't make their $100 million back, what happens to that company? There's no company no more. Who's making the drugs then?
No one.
So, yeah, that's rough. So it's up to you. I mean, you could definitely make an argument that you could blend it. Yeah. I mean, do you owe your investors? They trusted you with their investment, and you're supposed to make the money back. Yeah. Okay. Do you owe mankind? All right. Now, in the last 15 years, people would say you owe one thing: stockholders and screwmen. That to me is a major step back, but that's just my opinion. Okay. There's no reason you can't make a good buck and help mankind, but at any rate, it's an interesting ethical argument. At any rate, let's go here. Let's talk about the math. What's the cost of producing N pills? 0.4. Okay, let's do a quick doodle off here. Here's N, and here's the total cost. At 0 pills, what's the total cost? 0. Nope. Total cost of making 0 pills. $100 million.
Oh, yeah.
You have paid out $100 million, and you have made 0 pills. 1 pill. What's the cost of making 1 pill? $100 million and 40 cents. What's the cost of making 2 pills? $100 million and 80 cents. 3 pills? $100 million, $1 and 20 cents, and so on. Okay. So, what is the total cost of producing N pills? $100 million plus 0.4 N. You follow? We all agree with that. Okay, cool. What about a function for the unit cost, or the cost per pill? What do you think here? What'd you say? No. What's the cost of 1 pill? How soon you forget? What's the cost of 1 pill? $100 million and 40 cents. So what's the cost per pill if you make 1 pill? $100 million and 40 cents. If you make 2 pills, what's the total cost? $100 million and 80 cents. What's the cost per pill? Okay, you just said the 2 pills cost $100 million and 80 cents. Now divide that by 2 pills. What's the cost per pill? $50 million and 40 cents per pill, right? Now you notice then that that startup cost now just gets distributed among 2 pills instead of 1 pill. It's not laying all in that first pill. What if you make 10 pills? What's the total cost per pill? $10 million and 40 cents. What if you make 100 pills? Only $1 million and 40 cents per pill. What if you make 1,000 pills? $100,000 and 40 cents per pill. What if you make 10,000 pills? $10,000 and 40 cents per pill. Still pretty pricey per pill. I think you'll agree. Yes? If you make $100,000 pills, then the cost per pill is now only 1,040 cents per pill. That said, the unit cost is the total cost divided by the number of pills. So the total cost is 100 million plus 0.4 n divided by n. You with me? Now we were also, if we look at this a different way, couldn't we split that fraction and say it's that pill's portion of the 100 million plus 40 cents for every 40 cents it costs to make. Yeah? Now that's economy of scale. If you're going to lay out $100 million to make a pill, then you better be making a whole lot of pills. So are you going to go for some obscure disease that only 7 people have? Probably not. Those are the last diseases to get cured. It's the big ones that draw the money. You with me? All right, so after how many, unless your kid has the disease, like you're all over. After how many sales does the company break even? Say it again. When 75
Equals.
what's the revenue? How much you collect?
I did 74.
75 and I know what you're saying, but I'm going to do it this way. 75 in, when the revenue, $75 per pill times how many pills equals? The unit cost or the total cost?
Total cost.
Total cost. So that's 100 million plus 0.04 n. And that is n equal 1,340,000. How many you said again?
I rounded up to the
So the nearest pill, 1,340,483. So say you were a company and you sold 1 million pills. And at that point you've got your money back, yeah? Is it ethical then to keep charging $75 a pill? Or should you maybe drop the price? Or would you make more money if you say, screw $75 a pill, let's really stick it to these fools and jack it up to $1,000? And there are absolutely pills that cost $1,000 per pill in real life. Now is this to me, not cool. Now there's actually a business model that says buy pharmaceutical companies, not make drugs, buy companies and find companies with drugs that will save lives and jack up the price to like hundreds, tens of thousands of dollars because Medicare will pay it. Now but I'll let you think of that one yourself. To me, that's just, they might be rich, but they're going to hell. What? What did you say?
I think it's divided by 9.
Divided by what? It's the cost per pill. So you'd have to take the total cost of all the pills and divide by how many pills you made. Yeah? Okay. That said, let's talk, as the number of pills grows without bound, what is the cost per pill approach? Now we kind of did this talking it over. As you make more and more pills, doesn't that startup cost get divided up among more and more pills, yeah? And so if we take the limit as n goes to infinity of the unit cost, we could look at either one. Let's look at the first one, 100 million plus 0.4 n over n. We does the cost eventually approach if you just make
0.4.
it just becomes or approaches the 40-cent cost per raw material. Because the startup cost is distributed among so many folks. Yay? Sure. Now think of this calculus-wise. Think of this in terms of end behavior. Do you agree that in terms of end behavior, it's about the greatest powers? Yes. Yeah? All right. That's good. Let's go to the back. Also, this is really not in the book till set 98, but I gotta get in an earlier because it's a big idea, and I'm gonna eventually have to put these in the AP tests that you're taking. So, there is a short way to do this, but I'm gonna definitely do it the long way at least once or twice, just so you understand what's going on here, and it's not just some mindless shortcut. So, check this out. You see where I'm at?
Yeah.
Okay, cool. Now, it's tempting to say, well, the derivative, the antiderivative is just a function, yeah? And you're pretty kind of right, but not really. So let me slow down. And eventually, we'll get to a quicker way, but let's see it kind of drawn out process. If I were going to do that, it's really 3 steps. I would first do the inside, which is to take the antiderivative. What's the antiderivative? And using the fundamental theorem, I would evaluate it at 3, then x, yeah? When I evaluate it at x, I get x squared minus 2x, and when I evaluate it at 3, I get 9 minus 6. All right, now I'm going to take the derivative. What's the derivative of x squared? 2x, and the derivative of negative 2x is? And what's the derivative of 9 minus 6? 0. Okay, so you can see that, yes, sure enough, it is the derivative and the antiderivative are inverses. That's called the second fundamental theorem, that those are inverses of each other. But x goes in. All right, now, be careful though, because there are little gotchas here. You think you can just mindlessly crank stuff out, and so people would say 2x minus 2 here, and that is wrong. That is wrong. If you switch the bounds, then you get something like, well, yeah, you're going to get, first, you're going to get 9 minus 6, and then subtract x squared minus 2x. Oh, goodness. And then because it's being subtracted, now, instead of the derivative being the antiderivative, it's the opposite. It's negative 2x plus 2. Opposite sign. You follow? Now we could have rectified this by using the integral rule. Switch the limits and make it negative, yeah? And that would have been the same. All right, last but not least, what do you reckon this is? What's your theory here? 2 sine of x minus 2. We'll see. Okay? The antiderivative first is t squared minus 2t, yay? From 3 to sine of x. If sine of x goes in, then I get sine squared minus 2 sine minus 9 minus 6 or 3, yeah? Okay, now here we go, taking the derivative. What's the derivative of sine squared?
2 sine x cosine.
2 sine x cosine x. There's a chain rule here. Minus 2 cosine of x minus 0. Now, if we look at this, it is 2 sine of x minus 2, but times cosine of x. In other words, when there is more than just a plain old x up there, there's a function, then there is a chain rule component, and it is not just 2 with the upper limit minus 2 with the lower. You with me? All right, so be aware. Let's go with other replacement answers. This is pretty easy compared to sometimes these extra problems are rough. But this one is easy. What were your asymptotes for 2a? X equals negative 3 and y equals x minus 3. There was a slant asymptote. Cool. B, asymptote or asymptotes? Just got y equals x.
Yeah.
Y equals,
C, can you go over C?
I can go over C. Can you go over C? What'd you get for the asymptotes? Anybody?
X equals plus or minus
That's true. And
y equals.
there you go.
Mr.
And behavior. Yes.
Do we put in the
Never. When you integrate. Yeah, when you integrate, you do. Okay, we'll go back over those. 3, you have x-intercept at 2 and vertical asymptotes at 1 and -1, yes. And this is a dumb case because it was more like the old school x-axis kind of asymptote. Did you do that kind of thing and that and that? We? I should do that one. I should have given him slant S. I don't know what it's going on. This has x-intercepts at -2 and a vertical asymptote at +2. And the end behavior is a horizontal asymptote at positive or negative? -3. Because you have to look at the sign in front of the x as well. And the graph looks something like that. Oui. And then, what'd you get here? 2x minus 9 log yes. Okay. What about 5? True. Excellent. And 6. It is big. Okay. Questions? Questions on the front or the back? 5 on the front. What's the front? Is the front the my side or is front? Okay, so replacement 5.
16 on the back.
16 on the back. 2C. Check. And alrighty then. Let's begin. Doobie-doo. Might have to finish tomorrow, but that's fine. Review 5. Okay. What do you have to do first? What's the first thing you gotta do? You gotta divide. If it's a greater power in the numerator, you have to divide first. Did you synthetically or long divide? You could divide. Long divide. Alright, so x minus 2 into x squared plus 3x plus 1. How many times does x go into x squared? X times. X squared minus 2x. Change signs. Draw the line. You should get 5x plus 1. How many times does x go into 5x? 5 times.
Good morning, Dublin Jaguars.
Change signs. Draw the line.
Please begin. I pledge
Pledge
allegiance to the flag of the United States of America and to the republic for which it stands, one nation under God, indivisible, with liberty and justice for all.
So, the remainder does matter in these, and we need to now integrate the new.
Laundry room items from last semester. All items will be donated on Friday. He shaved his beard and recently adopted a brand new stylish monastic contour looks to help support retweet. Congratulations to Mr. Hagel for being the February Teacher of the Month.
1/2
We are grateful
x
for everything
squared
he does for our community and his
plus 5x, and then the log you can see. You could use sub that, but you don't have to.
Students, remember, you can only
Cool.
check out Chromebooks for 7th hour during the 10-minute passing period before 7th hour. Once the bell rings, you can no longer check out a Chromebook. Thank you.
Well,
All members of Girl Central,
16.
Friday we have a meeting. Make sure to sign up in your designated classroom. Come have some fun this Friday.
Is that girls or boys?
Western Colorado
Oh,
University.
so we don't have boys?
Western Colorado will be in counseling today during 7 hours. The campus is at 7,700 feet in elevation, which opens up opportunities for outdoor work in biology, geology, and environmental studies. Stop by and check them out. Boys mentoring will meet tomorrow in your designated rooms for attendance, and then mentors will escort mentees to the small gym. Please sign up in your room.
All right.
You still have 3 more opportunities to see the Zelda the musical. Performances are tonight, Friday, and Saturday at 7 p.m. Student tickets are only $5 at the door.
Seems like there should be 2 places to find, but here we go. How do we find slope equal to?
Tickets for adults at the door will
Derivative
be
equal to.
$12.
So find dy dx that equal to 2.
Be an amazing show. Honor rolls for the fall semester will be posted in the main office. Please review the list to make sure students are on the correct list before Friday. We will be publishing the honor roll in Jaguar chart.
Okay, so I get that the derivative is negative x over y,
Hey
yeah?
Jack, Valentine's Day is quickly approaching. And what better way
If I
to show
set that equal to
that
2,
someone how you feel than visiting the Sweetheart Shop?
that implies
February 7th to 12th. Chocolates, roses, cards, hugs, and
y is negative x over 2, yeah?
Hear ye, hear ye. Are you or will you be in high school? Do you love to write
So-
and take pictures? Do you want to make great friends? Come to the Yearbook Interest
I don't know
Meeting
if that's the
Monday,
best way to
February
go, but
21st.
besides that, it also has to be on the circle. So we're going to put those 2 together. So it might be something like x squared plus x squared over 4 equals 25, or 4x squared plus x squared equals 100.
Psychology meetings are 7 hours a day in the auditorium.
You get the idea.
Signing up for AP Psych, be sure to attend this meeting. If you're planning to take AP English next year who have not completed the sample essay, need to do so on Monday, February 10th during 7th hour. Sign up with your English teacher before reporting to Ms. Hobbs' room. See Ms. Hobbs immediately if you have a conflict.
Alright, you follow?
Interaction effort. There will be a meeting for those interested in the
Okay.
second semester of
To
People's School
see.
Project today, February 6th during 7th hour in Ms. Cook's Signature. Please sign up for your
Okay.
social studies teacher and then come to Ms. Cook's Signature.
So,
See you there.
first of all, do you agree that there are no zeros?
For your daily day today. Happy
so
World Nutella Day.
I set
That's all you're not
equal,
supposed to
the
have.
denominator equals 0, and that's where this guy came from. That's the zeros of the denominator, right? For for equal powers, dividing is possible, but not necessary. For equal powers, it's easiest just to look at n behavior and say that's negative 1/2, and that's cool. Okay? Alrighty then. Have a lovely day. Be nice. Sure. Yes. We finished it. The other class didn't finish their questions, but you guys are fast. Doobie-doo.